Hello all, welcome to Tech Capture. So in this video we are going to learn about AWS networking. So we are going to cover all AWS networking concept with a hands-on. So we'll be covering all basics as well as advanced concept in the single video. So this video might get longer, but just stay tuned till the end if you want to get a good understanding of the AWS networking concept. Sometimes it feels difficult to get all networking concept because there are a lot of terminologies, a lot of services available in AWS, and each of these components have the different functionality. So I'll try to explain all the components of AWS networking in this single video with a hands-on demo and the practical use cases. So it will be easier for you to understand and grasp all the concept in the single video. So I'll just request stay tuned till the end and just follow along with me, and I'm pretty sure you will get all AWS networking concept very clear at the end of this video. Okay, so what we are going to cover in this video, so let's see that. So first we'll start with the networking basics, then we'll see how we can create a virtual private cloud in AWS. So what are the different components, what are the subnets, what is private subnet, what is public subnet, what is a route table. We'll see what is a default VPC, what is internet gateway in VPC, what is NAT gateway, when we should use a NAT gateway, when we should use internet gateway, what is a VPC endpoints, what are the different type of VPC endpoints, what is elastic IP, what is a NACL or a network access control list, when we should use a NACL, what is the difference between a NACL and security groups, what is a VPC peering, when we should use a VPC peering, what are the significance of VPC peering, what is transit gateway, when we should use transit gateway, what are the different connectivity option we are having in transit gateway. That also we are going to see. What is a virtual private network, what are the different type, and when we should use a virtual private network, that also we are going to see. And at the end we'll see AWS direct connect. So almost all the concept we are going to see in theory. I would say the 10% theory, and rest 90% we are going to see a hands-on on our AWS console. So I'm just going to show each and everything whatever covered in this list on AWS console, and I just try to clear all your concept in this single video. Okay, so now let's get started with our networking basics. Okay, so first, what are the basics of networking? So I would say we should start with IP address. Okay, so whenever we are working with the networking, a very common term used is IP address. Though it is a very basic concept, I just want to clear all the doubts, all the questions you are having related to networking in this video. So if you already aware what is IP address, what is a public IP, what is a private IP, you can skip this part of this video and you can just move ahead on the further sections. Okay, but just I'll try to explain. So internet protocol or IP address is just unique identifier assigned to every device on a network. So always remember, just like your mobile phone is having a mobile number or your SIM card is having a mobile number, similarly to communicate anything on internet you should have a IP address. Even if you are using your mobile, your TV, your laptop, whatever is connecting to the internet, it is having the IP address. Okay, and for IP address there are two types. One is public IP and second is a private IP. Okay, so the public IP is just assume you are having two names. One is your pet name, which your only family is aware about. No one is aware you with your that pet name outside your house. That is called as internal IP. Okay, just like a internal IP. So that is internal to your network. And a public IP, I would say the example of your official name. So everyone, your school friends, your college friends, your office colleagues, everyone will know you with your common name. That is your public IP. So whenever you want to access the internet, you should have a public IP. Okay, and then you can talk to internet using your public IP. But for a communication within your network, you can use a private IP. Now this might be confusing. I'll just show you an example on your local. So whenever you are connecting your laptop to the Wi-Fi, it is also having two IPs. One is your private IP, which is assigned by your Wi-Fi router to your laptop or your system. That is your private IP, and you also have one external or public IP which your laptop is using to access the internet or communicate over the internet. Let me show you that. Okay, just let me open CMD. Now I am having my CMD open. Just I'll type p config and it will show me some configuration. Now you can see what is the IPv4 address of my system, 192.168.1.7. So that is my internal IP which is assigned by my Wi-Fi router to my system. So how I would understand that it is an internal IP and not a public IP? So always remember your internal IP is having three ranges. Okay, so I'll show you what these ranges can be. So your private IP ranges can be 10.0.0.0 to 10.255.255.255 or starting from 170.16 or starting from 190.168. So currently my system internet IP or IP you can see is starting with 192.168. So you can see this is 190.168. So this is my private IP. Now how I can understand my public IP? So that is used to communicate over the internet. So you can check any of the sites. So there are multiple sites. Okay, so just you can type my external IP and you can go on any of the site and check your external IP. So I'll just go here and check my external IP or public IP. So it will show you a public IP. So this is your public IP. Okay, so this is IPv4 and this is IPv6. So IPv4 is always having this format. Okay, 4 octet, and your IPv6 you can see this format. So your IPv4 is always a 4 numbers separated by dot. Okay, 1 2 3 4, and your IPv6 is in the hexadecimal format. So IPv4 is most common and you can see on every of the device which you are using to connect to the internet. So now this is about IP address. Hope this is clear. What is IP address? So IP address is a unique identity assigned to any of the network which is connected to the internet or a network. Second thing, there are two types of IP address. One is internal, that is, and another is the public or external. So internal, which is used within your network, and external IP, which is used to access the services on the internet. Okay, so there are two IP. And what are the ranges of internal IP? So there are three ranges. Okay, so you can see these ranges: 10.0.0, 170.16 and 190.160. So these are the private IP ranges. So we'll be using these ranges whenever we are going ahead and creating our VPCs in AWS. Okay, so hope this part is clear now. Now we'll talk about one more important concept in a networking. So these concepts are important in any of the cloud or any of the networking, regardless you are working on AWS or you're working on a Google Cloud or Azure. So this concept you will be always using there. So this is CIDR. So what is CIDR? That is classless inter-domain routing. So no one will going to ask you about the full form. The only things you have to remember what is a CIDR range and when we commonly use it. Okay. So CIDR is nothing. You can say it is a method of defining the IP ranges. So suppose whenever you are creating or designing your network, you have to get the CIDR range. So suppose you are creating a network where you will be needed a thousands of virtual machines, then you should need a thousands of IPs. But how you will make sure you will get these 1000 IPs in the same range? So you have to define that CIDR range. So you can see how CIDR work. The part of the IP address is defined by the CIDR prefix. So you can see this is the notation /24 /20. So this kind of definition we can see that is called as a CIDR notation. So whenever we are creating the VPC, we have to define this CIDR range. But how this will make sure how many IP you are having in your network? So /24 you can pay attention to the number after this slash. Okay, so suppose this is /24. So how you will calculate the IP? So I'll just give the mathematical expressions here. So you have to divide 24 from 32. Okay, so 32 minus 24 is 8. So your total IP will be 2 raised to 8. So I have just explained here 32 minus 24 is equal to 8 and 2 raised to 8 is equal to 256, and then you have to minus 2 IPs or 5. So in AWS you have to minus the 5 IPs. If you're considering only for VPC, you have to minus 2 IPs. So basically you will have total 256 IPs. Okay, so this minus 2 you can forget for now. You will have total 256 IP if you are using /24. So let me just go to the one of the site and just try to explain you how these IP ranges with slash notation will work with a CIDR. I'll just go to one of the site CIDR calculator, and I'll just show you what it means whenever we are talking about any of the CIDR notations, how we can calculate the IP. I'll take this example. Now suppose if we are considering that we need IP range for our VPC, that 10.0.0./24. So how many total IPs were there? So let me just click on calculate, and it will show you total 256 IPs will be there. The calculation I just shown you. So this calculation is just like 256, and minus 2 can ignore for now. I'll explain you when we are creating the VPCs. So suppose I need a more IPs. So how you will get more IPs? So you have to just decrease this number. So suppose if I do in 22, so let's see what will be your IPs. So now you see you got 1024 IPs. Let's see, I did 20. How many IPs you will have? Now you will have 4096 IP. So based on the number of IPs you need in your network, you will decide your CIDR notations. So this is your CIDR range that you have to define for creating your VPC, for creating your subnet, and that we are going to use in creating a VPC. So hope these two things are clear now, what is IP address and what is a CIDR. We'll see what is a virtual private cloud or VPC. So I'll just show you a theoretical definition about VPC. I'm not going to drag you about a lot of theory stuff here, and we'll directly jump into the hands-on on our AWS console. So here basically a VPC is your virtual private cloud. It's a logically isolated network within the AWS cloud. So suppose you have to create any virtual machine or your AWS EKS cluster. So for all these stuff you need a network, because AWS is Amazon Web Service. Cloud is nothing but the services which can be accessed over the internet. So for that you need a network. So network is, so here you cannot keep your physical network on cloud. You have to create a virtual private network. Okay, this is your virtual private cloud. We'll see a component of a VPC. So each VPC is having a different component. So first we'll have your VPC. This is your regional resource. So each of your region will have a separate default VPC, and whenever you want to create a VPC, you have to create your VPC within a particular region, because VPC is a regional resource, and within VPC you will have a subnet in a AZs. So subnet is again a component of VPC. Here I can show you the simple diagram. Here within one region, let's say suppose US East 1. So within US East 1 you will have your VPC, and in US East 1 there are 3 AZs. It can be US East 1A, US East 1B, and US East 1C. So you can create a subnet within each AZ, and these subnets will be again a part of your VPC. So VPC is your virtual private cloud, and again you segregated your network within a 3 availability zone with a different CIDR ranges, and that is your subnets. Again you will have internet gateway, you will have route table, and each and everything we are going to cover in this video. So now let's go to the AWS console, and we'll first see what is VPC on a AWS console now. So I am in my AWS console now, and here I'll go to a VPC page. So simply type VPC here. It will just show you the option to go to the VPC page. So in each region, so currently I'm in Mumbai, so it can be your AP South 1 region. So whenever we create this AWS account, so in each region there will be a default VPC created. Okay, so here you can see, so I just open this region and I haven't created anything manually here. Still you can see one VPC. So if I go to the VPC, I can show you the component. So each of this region will have the default VPC. So default VPC will have all already set up components, so you can just start using it without making a lot of configuration. Okay, so what are these components of this VPC? This is pretty clear to show here with the default VPC. So how we can understand this is the default VPC? If you just scroll to the right, and you can see the default VPC is yes. So it means it is the default VPC within your region. So I just click on this, and now we'll see the resource map of this VPC. It will show you what are the different components available within your VPC. Okay, now you can see the details here, so I'm not interested much in detail. I'll go to resource map, and here you will see the things we are looking for. So this is your VPC, and within your VPC is in AP South 1 region. Okay, and there are three subnets. So what are the three subnets? AP South 1A, AP South 1B, and AP South 1C. So your VPC is regional, but your subnets are within your availability zone. Now the subnet is having again a route table. So what is route table? We'll see in details. And again, after route table, you will have your network connection or IGW, that is your internet gateway. So currently you can see different components here. One is VPC, which is a regional. Then you will have subnet in each AZ. Then you will have a route table. Then you will have an internal gateway. So these are the things required to use your VPC with a fully functional way. Okay, so this is the default VPC. Now what is these details? Okay, so if you go to the VPC, here you will see IPv4 CIDR. So to create any VPC, you have to provide this CIDR range. Now what is a CIDR? Hope you understood the CIDR now. So now when you are giving /50, so each default VPC is having /16 CIDR, and each subnet is having /20. So if I go to the subnets now within your default VPC, it will have three subnets, and each is having the CIDR of /20. So if you see, each is having IP addresses of 4091. So these are the available IPs. So you can use these IPs here, and each is different in availability zone. So that is the default VPC. So if you want to create any virtual machine EC2 instance, you can simply create and use the default VPC. You don't need to worry of much of the configuration, routing, and all other stuff. But this will not clear your concept if you are using the default VPC. So for that, we have to use our custom VPC. So I'm going to create my first VPC here now. So I'll go to VPC. Okay, so I'll just create my first VPC, and then we'll start launching our EC2 instances in that VPC, and we'll see what are the different configuration we need to work with our VPC network. Okay, so now I'll just go and create a VPC. So here there are two options. You can either create VPC and more. So what more component it will create? So it will create your VPC subnet and your route tables and a internet gateway, and also your endpoint, VPC endpoint. So in single click you can create all these components, but you will not understand what the functionality of each component. For that we will just simply go with the VPC. Okay, so I'll just create my VPC. I'll just give the name as demo VPC. Okay, so here you have to give the CIDR range. So I can use 10.0.0.0/16. As I already told, it should be a one of the private range. Okay, and then I'll just create my VPC. So my VPC is created here. Okay, so you can see a resource map here. So currently I'm having only VPC. I'm not having any subnet. I'm having one root server. There is no internet gateway or any of the other connections. So currently I created only a VPC. Now I have to create subnet. So there are two types of subnet. So what are these two types? Let's see first. There are two types of subnet. First is a public subnet, another is a private subnet. So this is a simple term. What is the public subnet? Subnet which can communicate to the internet via internet gateway is a public subnet. So suppose if you have internet gateway in your subnet, it means this is a public subnet. If you do not have internet gateway, this is a private subnet. what is internet gateway? So internet gateway is a component which used to connect your services to the internet. So this is a simple term. Now we'll go in our VPC and we'll create two subnet. First we'll create one private subnet and then we'll see a public subnet and we'll see what is a difference between public and private subnet. Okay, so let me just go to the our VPC and create two subnets. One is public subnet, one is private subnet. So I'll just first filter my VPC. So I just want to see the subnets. So I'll just go to subnet. There are three subnets, so these are belongs to the default VPC. So I'll just filter subnets here based on the VPCs. So I just want related to the demo VPC. So currently you see there are no subnets available for demo VPC. So let's create a two subnets here. I'll just create subnet. I'll select VPC for demo VPC and we have to create first subnet. Okay, so this is our main CIDR range. So how many IPs we are having? Let me show you that. So we are having CIDR calculator. Okay, so we can check how many IPs we are having with this range. Okay, so we are having 65,000 IPs. Okay, so I can use the IP for my first subnet. Let's say /20. So how many IPs will be there? So there will be 4,000. So I can create two subnets with the /20 range. So I'll just create first my public subnet. I'll just name it as a public subnet and I want to use it in zone A. So I'll keep it as a zone A and I will choose AZ as a A. And this is my VPC range, so I do not have any other option to select this one, but here I can choose so 10.0.0.0/20. So this is a 4096 IPs, so I want to use this IPs. Okay, so all rest things I will keep as it is. So this is my public subnet. Now I need one more subnet for private. I'll just use the name as a private subnet. Again zone I want to use A. Here if I use the same range it will overlap and it will throw an error. So here what I can do, so suppose I'll try to create it. Let's see. CIDR address overlaps with existing subnet because my subnet 1 is having same ranges. Okay, so you can see subnet 1 is having same range, subnet 2 is also having same range. So I'll just change the range, so it is very pretty easy. I'll check the next available range. I have to just simply click on here and it gave me next range starting from 16. I will use this. Now I'll just try to create subnet. Now ranges are not overlapping and it will create a two subnet for me. But before understanding what is the public subnet and what private subnet, so let's see and go and launch EC2 instances in both the subnet. So I'll just open a new tab here and I'll create two EC2 instances in both the subnet. So I'll just go here, okay, and I'll try to launch EC2 instance in both the subnet. So first I'll launch in private subnet and then I will launch in the public subnet. But these two subnets, it is for now just the names are public and private, but these are not actually a public subnet because public subnet should have the internet gateway associated with it. Currently we do not have any internet gateway within our VPC. So if I go to internet gateway, so you'll see there is no internet gateway. It means both the subnets are currently by nature a private subnet. I just named it as a public subnet. I will make it public subnet. Before that I want to show you what errors we get if our subnet is not public. What are the differences when we use a public subnet and private subnet. So yeah, so let me go to the instances. I'll just click on a launch instance. I'll just go with the default configuration. I'm not going to make any complicated configurations here, and I'll just create a VM public, or I'll just give public VM. Okay, so I will use by default free tier eligible default. I'll keep the configuration default. Okay, so here we have to select. By default it will choose your default network, but I'll go and choose our demo VPC. I don't want to use default. I want to go with the demo VPC, and it will, now it is taking your private subnet. I want a public subnet first, so I'll create a virtual, I will create a EC2 instance in public subnet. So this we have to enable to also assign a public IP. Okay, we have to create security group. So when we should use the security group, it is just allowing traffic to our EC2 instance. Okay, so I'll explain you in detail what security group in further part of the videos. So first I'll name it as allow SSH or allow fix. And what I'm going to allow here, so you can see the by default showing us to allow traffic on port 22 from anywhere, so we can SSH into the virtual machine. So here we are allowing traffic on port 22 to allow SSH into the virtual machine. Okay, so rest of the configuration I will keep default, and I will just launch instance. So it will take a couple of minutes to launch my instance, so we'll just wait for it, and then we'll see if we can SSH into the instance. Okay, instance is available now. Let's see, go to the EC2 page. Okay, let's refresh it. Okay, it is instances are running now. Let me click on it and let's try to SSH. So you have option here to connect. I will just use this option, click on connect. Okay, now you can see some warning is here. Associated subnet is not a public subnet. We named it a public, but it is still not a public. Okay, to use EC2 instance connect, your instance must be in a public subnet. It means we created a virtual machine in a public subnet. It means the name is only public, but it is still not a public. So we have to remove this warning. How we can remove? For that we have to create an internet gateway and add this to our VPC. So if I try to connect without creating my subnet as a public, what will happen? So let's try it. I'll just try to connect it. Okay, and we'll see what error I'll get. Okay, so we got an error. EC2 instance unable to connect to yours. EC2 instance connect is unable to connect to your instance. Ensure your instance network settings are configured correctly. Okay, so our settings are definitely not correct because we mentioned it is a public subnet, but it is not actually a public. To make it public, we need a internet gateway within our VPC. Okay, so first see what is a internet gateway. So what is a internet gateway? So internet gateway enable resources in your public subnet connect to the internet. Okay, so it allow both inbound and outbound traffic. Now here we are getting error because of the inbound traffic, even though there is traffic allowed on port 22. So my remote IP, it means my systems or laptops IP cannot communicate with the external IP of my virtual machine. This is because there is no internet gateway. So it is just like my EC2 instance do not know what is the IP address of my system, or there is no medium to communicate these two IP address each other. So you can see, for example, EC2 instance in a public subnet can send request to an internet, or user can access EC2 instance via a public IP. So this is possible when you have internet gateway, but only having internet gateway is not sufficient. So for that we need a route table. So what is a route table? And we need entry in the route table so that any traffic outgoing should have target to the internet. Okay, so let's see, this is my public subnet, so my traffic should route to the internet gateway. So this is my internet gateway, and using internet gateway my traffic will either go out or come in using internet gateway. And within private subnet it cannot access internet because there is no internet gateway available. So that is my private subnet. In route table we should have the entry that if any traffic going outside on the internet should go to the IGW, that is my internet gateway, but that entry should be in the root table. So first we need to understand what is a root table. Okay, so you can see a route table is just like your map that directs network traffic. So suppose you are using the Google map and you have to just go from one city to another city. You will just give the destination and it will show the route how you should go. You should first go to this city and then go to this city, and this route you can follow to go to your destination. Same way we have a route table. So for any destination we have to get target how your traffic should be routed. So I'm just giving example here. So if your VPC is having address 10.0.0.16, your target should be local. It means any IP address belong to a VPC is within your local network. Okay, same for IPv6 within your local network. If any other VPC connections I am showing, if any traffic needs to go to the other VPC address, let's say example 172.30.0.6. So this is your peering connection, so it should go to your peering connection. If any traffic going outside your network 0.0.0.0, it should go to the IGW, that is the internet gate. So all this routing should be defined in your route table, and this is a very important component of any of the VPCs. Okay, so each traffic you have to define how your traffic should go out of your VPC. Now I'll just go to my VPC, I'll create internet gateway, I'll create a route table. Okay, so let's go to our VPC and subnet we already created. We created one virtual machine, that EC2 instances within my public subnet, but it is not acting as a public subnet because there is no internet gateway. So let's go create internet gateway, create route table, and we'll see if we can access that EC2 instance. Okay, so let's go to the console. So I am within my VPC now, which we created, that is a demo VPC. Currently there is no internet gateway, so I'll simply click on internet gateway. I'll just give name as my internet gateway and simply create. So creating internet gateway is pretty easy. There are additional steps as well to make it work along with your subnet and make your subnet a public subnet. So first is you have to attach it to the VPC, and second thing, you have to create entry in your route table. So let me just attach to VPC. Okay, I'll just attach it to the demo VPC. Now if I go to the internet gateways, okay, so it will show my internet gateway is available and attached to my VPC demo VPC. Now let's try to connect now. Okay, so I'll just close the previous instance and let's try to connect now, because now we have internet gateway but still we have this error. Let's try to reload it. And let's see if we still have that warning or error. Okay, it is still having, but we have internet gateway now, still it is showing an warning. Let's try to connect and see if we still face an error. Definitely we'll face this error again. Why? I'll tell you, because we are still missing one step to make it our subnet the public subnet and use internet gateway to access our connection. This is the internet. Okay, so we still got the same error. It's still not working. What we are missing? We are missing the route table. As I said, how my VPC will understand, okay, we have internet gateway and we should use this internet. So for that we need a route table. Okay, so if I go to route table, there is already one route table. Okay, so this route table is already there. So if I go to my VPC, okay, so if you see the resource map, the route table is already there and a network connection is already there. So if I click on a route table, I'll just open the route table. So this route table is a default main route table of my VPC, and within this route table there will be one entry which points to the local, which is my VPC IP ranges. So let's see what we have in our route table now. So currently we are having this one entry which is going to internet gateway. Okay, if you go to subnet association, there is no explicit subnet association for this root table. So we have to create a new root table for our private subnet, and we have to create separate for our public subnet. So first I'll go to the root table and will create a root table for my public subnet. So I'll just type public root table. I'll just name it as a public RT. VPC will be demo VPC. I'll create root table. Okay. And subnet association, so that will not work only, so we have to associate it to my public subnet. So here I'll go edit subnet association, I will check public subnet and I will save association. Okay, now I have only one route, so this is my VPC traffic. Anything I need to access within my VPC, it should point to my local network. But what if I need to access the internet? So I need to add that route. So anything I need to access on internet which is not within this range should go to my internet gateway which I created. Okay, so I created one internet gateway, my internet gateway, and I'll save the changes. Now I'll show you what will happen if I go to subnet, which is my public subnet. I'll go to root table. Here you can see anything within my public subnet. Okay, anything going within this VPC use the local, anything going outside will use my internet gateway. So this is my public subnet. I'll create one more root table for my private subnet. So just select VPC, create root table. Okay, subnet association, private. Okay, so this is my private. Now in private root table, I will not add a route for internet gateway because that is the difference between public and private subnet. So my public subnet will have internet gateway and it will have a route to access the internet through the internet gateway. So that is my public subnet. Now my public subnet is a fully functional public subnet. I can prove that. So let's go back to the EC2 instance and try to connect now. So I'll just go here to EC2 instance and try to connect now, and this error should be gone. If I reload, so this error, this warning is gone now, so we are not getting that this is not a public subnet. And let's try to connect now. Okay, so it should work this time because now we are having fully functional public subnet and it should have the internet gateway as well as it is having the route within our internet gateway. So it should work this time. Yeah, you can see now I am within my EC2 instance and it worked perfectly fine. And this is how we can create our VPC, we can create our subnet, we can create our internet gateway, we can create our root table, and we can access internet using a public subnet. Okay, let's enable the service now. Okay, now let's see if Nginx is started. Okay, you can see the Nginx is active and running now. So let's see on the public IP address of our instance. So this is our instance. Let's open and check the public IP address. So this is a public IP address. I'll simply click on open address here. Okay, and let's see if we can get the dummy Nginx default page on this public IP address. You can just copy this IP address if it is taking time and just type HTTP. So we do not have SSL certificate, so we'll just check on HTTP. So this is also open. So see, you can see it is timed out. It took too long to respond. This is because if you remember, we allowed traffic only on port 22 to SSH. So we haven't allowed any traffic on a port HTTP. Okay, So for HTTP traffic, we do not have any rule. So where we can enable that, so that we can enable in a security group. So if I go to instance, so I have one security group. Okay, so this is the security group allow traffic we created while creating our EC2 instance, and within that we only allow traffic for port 22. So let's see the inbound rule which we created. So here we have inbound rule. So let it is reload. So here we have only one inbound rule on port 22. So let me create one more inbound rule. I'll just select the HTTP. Okay, so it by default port 80 and it should be accessible from all the internet. Let me save the rules. Okay, now I have created inbound rule to allow traffic on port 80 as well, where our Nginx is running. Now if I reload this page, it should show me a default Nginx. Let's see. Okay, now you can see displayed welcome to Nginx. It means traffic is allowed on port 80 and it is working fine. So let's go back again and delete this rule. So I'll just delete this rule. Okay, I'll just go back and delete this rule, save rules, and let me reload this again. And it will again timed out because we just removed any inbound rule which we are having. So we do not have any deny rule there. We can just allow traffic or deny traffic, allow inbound or outbound. So in outbound, let's see what we have. So on outbound also all traffic is allowed. Okay, so it means can be allowed any traffic. If I go to EC2 instance and try to ping google.com, I'm getting response because all outbound traffic is also allowed. Now you can see Nginx is not accessible. I will just delete this outbound rule as well and let's see what will happen. I'm just deleting the existing rules and just trying to see what impacts we are having on our instance. I'll just save the rule. Now there is no outbound rule. Okay, let's check here now what will happen. Okay, let me do ping again and let's see if it reached to Google now. So here earlier before we are having outgoing rule, you can see 20 packet transmitted, 23 received, 0 packet loss. So it means the outgoing traffic was allowed and we are able to reach the google.com. Now you can see I tried to ping google.com but it just stuck here. And you can see now 72 packet transmitted, 0 received, 100% packet loss. It means it is not able to reach to Google because there is no outgoing traffic allowed. And Nginx also not accessible. Let me go back again and put some rules back. So first I'll put inbound rule again and I'll just allow HTTP traffic on port 80 to allow Nginx service accessible, and also I'll create outbound rule to allow all outbound traffic. So you will get better understanding of the security groups and how security groups will work. We'll just add one for HTTP, save rules. Okay, let's see Nginx now. It is working fine. Let's go back to outbound rules and add one more rule for outbound traffic. We'll just add all traffic, save rules. Let's check the ping again and it's working. Let's see 5 packet transmitted, 5 received, 0% packet loss, and earlier it was 100% packet loss because we are not having any outbound rules. So this is how we can use security groups to allow traffic in and out of our EC2 instance. So one thing to remember, we do not have any deny rule to just deny traffic to a particular IP address or particular range. So we are only having allow rules. So what if we need to deny a particular traffic? We have to deny traffic for particular IP ranges. How we can do that? So that we have a network control, that is a NACL. Let's see what is NACL is having. We'll see what is a NACL or a network access control list. So if you remember, we just recently worked on the security group where we can allow traffic at a instance level, but there was no option to deny any specific traffic. So suppose I want to deny traffic for specific IP, that I could not do using the security groups, but using a network access control list I can do. Okay, so what is network access control list? It allow or deny specific inbound or outbound traffic at the subnet level. So the security group is at instance level, the network control list is at subnet level. So it can allow, it can deny. So whatever you do, it will be applicable to the all the instances within your subnet. If you are having 50 EC2 instances, it will applicable to your 50 EC2 instances. So you can use the default NACL. By default, all inbound and outbound traffic is allowed in your default NACL. I'll show you. Whenever we created the VPC, we had one default network access control list, so we can create our custom as well. We are going to do it in this video. Okay, so one things to remember, you can associate a network SSL to multiple subnet, where subnet can be associated with only one NACL at a time. Okay, so if we create a custom NACL, just the previous one will be removed. I'll just go to our subnet which we are working currently, which we are having EC2 instance, and we recently installed the Nginx on this and running the default Nginx service. So we'll go into that subnet, that EC2 instance, and we'll to just play around a network control access list. Sorry, network access control list. Okay, it can be called as a NACL, and we'll just play around, just allow some traffic, just deny some traffic. We'll see how it behaves. So let me go to the console now. So we were in our EC2 instance, we just tried to ping to the google.com to check the outgoing traffic, and we are using Nginx to test our incoming traffic. So we are having security group which is having outbound rule to allow all the traffic, and also having inbound rule to allow traffic for SSH port 22 as well as HTTP on a port 80. Okay, so now let's see the default NACL we had in our subnet. So if I go to a VPC, go to VPC, and let's go to the demo VPC. So we had a root table, and here you can see this is a default NACL we are having. So if I go to default NACL, it is associated with the two subnets. So we are having public subnet and private subnet. So default will be applicable to all subnets in your VPC. So what rules the default NACL is having? Why we did not face any issue as of now? Let me show you that. So in your default NACL, traffic, all traffic is allowed for inbound, and all traffic is allowed for outbound. So what I will do, I'll just create a new NACL now. So if I scroll down here, go to network access control list, I'll create a new one. Okay, I'll just create custom NACL. I'll select VPC, demo VPC, and I'll create. So it is created. Now you can see the default is associated with two subnet, custom is not associated with any of the subnet. What I will do now, I'll just select the custom, and I will just edit subnet association, and I'll just add this association to the public. Now my this NACL, custom NACL, will be applicable on my public subnet. Now here you can see what inbound rule it is having. By default, it is denying all traffic, even though we are having a security group to allow all traffic on port, you can see 80. Now let's see if my Nginx will work. Let me just reload this. My Nginx will not work because my NACL is here. Where is my NACL? Just showed you here. Yeah, here. So it is just by default denying all traffic. Okay. So what I will do, I'll just create one more rule. I'll just create one rule. Meantime, it just timed out. I'll just go here and I'll just update my NACL. Now one more thing, I'll just try to explain here. So I'll just give the 100. So lower the number, it will follow that. Okay, so if it is 0, it will just always go with the lowest number rule. And here what I want to do, I'll just want to allow on 80. So I want to allow port on 80. Allow. I'll select HTTP. Okay, allow traffic. Let's save changes and let's see even if we are having inbound rule, if it will allow now. So let's check. So here we got response. It took time to respond. And let's try to reload now and we'll see if our request is going there. You can see it will just keep loading. Why it is keep loading? There is one concept I already discussed about security group, that it is stateful. So now if I go to some feature of NACL, so this is stateless. What is mean by stateless? Which means they do not track state of connection and you need to specify both inbound and outbound traffic rules separately. Now I am able to hit the Nginx, but I am not getting the response back because outbound traffic is blocked. If I go to network ACL and here you can see the outbound traffic is blocked. What I will do, I'll just outbound, I don't care. I just want all outgoing traffic should be allowed. So I'll just allow outbound traffic here. So I'll just open the outbound. I'll just add new rule. I'll just give the lower number. I'll keep the all traffic allowed. Okay, I'll just save changes. So now you can see my outbound all traffic allowed and inbound allowed on port 80 only. So let's reload this now. Now it's working. So even though you had a security group, it will not work if you were having deny rule in your NACL. Now one more thing. So here in my NACL I am only allowing on 80 and not allowing on port 22. So let's see if we can log in into the EC2 instance now. I'll just try to connect. So it should throw an error. It should not allow us to log in into the EC2 instance because even though our security group, so here we are having security group allowing traffic. Okay, it is allowing traffic in security group. It is not allowing traffic at the subnet level. So it will decide what traffic should go to my subnet in and out, what should go out of my subnet and what should go inside of my subnet. If it is not going inside subnet, it should not reach to my EC2 instance. So your security group will not have any of the effect. Okay, so it will, this is the older one, so this is the newer. It failed. Now if I edit my rule again and I'll just allow traffic on port 22 as well, this EC2 instance SSH will work. So let me just create more rule. SSH, I'll just give here as well 100. Allow, save changes. So rule number already in use, I'll just give 101 and let's try to do connect now and let's see if it works. So this time it should work because now the traffic is allowed at the subnet level. If it is passing the subnet, then it will go to the security group. In security group also it is allowed, then it should work and should SSH into my EC2 instance, and you can see it worked perfectly fine. Now we worked on VPC, we created our own VPC, we created public subnet, we created private subnet, we created internet gateway in public subnet, we created EC2 instance in public subnet, we created a route table, we tried to access internet, we allowed traffic, we denied traffic on public subnet, but we are still not using the private subnet. So now what we'll do, we'll just create one EC2 instance in our private subnet and we'll see how we can SSH into it and how we can use internet on our private subnet. So let's go to the instance page here and I'll just create one EC2 instance in private subnet. So let's just go and launch a new instance here. We'll click on launch instance. So we'll go again with the default configuration. I'll just give the name as a private VM. So the most of the configuration will keep default. Okay, and while choosing the network, I will go with the our network, which is a demo VPC. Will not go with the default, and subnet here will go with the private subnet. Now in private subnet will not assign a public IP. Security group, we already have security group, so allow traffic I will use here, so it will allow traffic on port 22 and let's launch instance. Okay, now instance is launched. It will take a couple of minutes to show in running state. Okay, it's running. Let's open it and let's see if we can connect to this instance. Now you can see no public IPv4 or IPv6 assigned. So with no public IPv4 or IP6 you cannot use EC2 instance connect. So this cannot be used. So what we can use? We can use EC2 instance connect endpoint. So that what is this EC2 instance connect endpoint we'll see later. So first I will connect using this EC2 instance connect endpoint. So I'll just use this select endpoint. There is no endpoint. I'll go and create endpoint. So creating endpoint will be very easy here. So I'll just use my endpoint. Type will be EC2 instance connect endpoint because we need to connect to the EC2 instance with a private IP. Within you can see an elastic network interface that allow you to connect to the resource in a private subnet. VPC, I'll select demo VPC. Okay. Security group, I'll choose this allow. Select subnet, choose a private subnet and just create endpoint. So it should allow us to log in into endpoint. So let's see if we get the endpoint here. So it is still creating. So let's check the status. It's pending. Let's refresh. So it will take couple of minutes. Okay, now you can see EC2 instance endpoint is available. So let me just refresh here and you can see I can see the endpoint here. You can select this endpoint and let's try to connect now. So your instance is not having public IP address, still using this endpoint you can SSH into your virtual machine or EC2 instance within your private subnet. Now your subnet is a private subnet. It does not have an internet gateway attached to it. It does not have a public IP address. But using this instance gateway endpoint, you can SSH into your instance. Okay. Now I can see I am already within my EC2 instance. Now let's see if I can access the internet as well. So I'll just try to do. So it's stuck. So it means I'm not able to access the internet. So if I'm using the public subnet, I will use an internet gateway to access the internet using the public IP address. Then what should we do in case of the private subnet? Now still I want to access the internet, but I just don't want anyone from the internet can access my EC2 instance, but I just want outgoing internet traffic should be allowed. So in case I want to access the google.com, what option I'm having? So in this case, we can use a NAT gateway. So what is a NAT gateway? So let's see first what is a NAT gateway. So here, let's see, you can use a NAT device to allow resources in private subnet to connect to the internet. So the same use case we are stuck into. So we are having a EC2 instance within our private subnet that wants to connect to the internet. So we can use a NAT gateway. But how we can use the NAT gateway? So NAT gateway instance can communicate with the services outside the VPC, but they cannot receive a unsolicited connection. It means it just traffic will be allowed to the internet. So how it will work? So whenever you are using the NAT device to access the internet, what will happen? When sending the request to the internet, it will use the NAT IP or the IP address of the NAT device. So check here, we are having private subnet. We'll create one NAT device, NAT gateway in a public subnet. In public subnet, NAT gateway will use internet gateway to access the internet. Okay, so we'll see that. We'll go to the console and we'll create one a NAT gateway within our public subnet, and using that public subnet NAT gateway will access internet within our private subnet. So always remember, in a private subnet will not have a internet gateway attached. If we are attaching the internet gateway, then definitely it will become a public subnet. So now I'll go to the console and I will create one a NAT gateway. So let's go to the console now. So I'll just first cut here and let's see, 161 package transmitted, 100% package loss. It means it is not accessing the internet. So let me go back to the VPC and let me go to the NAT gateway. Where are we having NAT gateway? Yeah, here. I'll just go and click on create NAT gateway. So I'll give the name as NGW or NAT gateway. So subnet, it should be in a public subnet. Okay, so your NAT gateway should be in public subnet. So elastic IP, you have to choose elastic. I'll just allocate elastic IP and I'll just create. So once my NAT gateway created, I'll update the root table. Now currently if I go to my private subnet root table, so this is my private subnet root table. So it is having only one root, that is for local. But suppose if I want to access the internet traffic, I need to create additional route which should point to my NAT gateway. So I'll click on add route. I'll just select traffic. I'll choose NAT gateway in this case, and I will select the NAT gateway which I recently created. Okay, now let's see if my NAT gateway is created completely. So it is in pending state. So let's wait for some time, and once it is working, I'll be able to access the internet. So I'll just keep the command. So okay, I'll just use this command again, and as soon as my NAT gateway created, it should start working. Okay, so currently it's not working, it is just sending the packet but it is not getting received. Okay, so it is just a packet loss. So I'll just show you. So 100% packet loss 14 transmitted, not receiving. So just again execute it. It is pending, and as soon as a NAT gateway is a functional, as soon as this NAT gateway is available, this should start receiving the packets. So let's wait for a few minutes to get this NAT gateway available. Okay, NAT gateway is available. Let's check the EC2 instance. I'll just close it and try to do it again. It's still not. Let's wait for some time. Now you can see immediately it started getting the response. So earlier the few packets were missed. If I just do Control C, you can see 141 packets transmitted, 16 received. Means initially there was no NAT gateway, so it was dropping the packet. But if I do now, it will just show you 100% packet received. So this EC2 instance is not having public IP, is not having internet gateway. Still we are accessing the internet on this EC2 instance using the NAT gateway. So when we can use the NAT gateway, so whenever we need to access the internet on the resource in the private subnet or in the EC2 instance with a private VM, in that case we can use a NAT gateway. So hope this is clear now, in which case we should use a NAT gateway. We'll go further and we'll see what is a VPC peering. So first just try to understand in a theoretical way what is a VPC peering and why we need a VPC peering. So what is a VPC peering? Okay, so VPC peering, you can see it is a connection between two VPCs that enable you to route traffic between them using a private IP address. So let's example, we have two instances, EC2 instances in the same VPC. They can talk to each other using their private IP. But suppose I have one instance in VPC A and I have another instance in VPC B. So they cannot talk to each other using a private IP. They need a public IP and they have to travel through a internet. It will increase additional cost, it will lead to security issues. So to avoid that, I just want instance in my VPC A should connect to instance in VPC B using a private network. So how we can do that? How we can make them communicate using the private IP, just like they are part of the same VPC. So we have to make some connection between them. So it's kind of peering. So let's say VPC A will decide, okay, we'll talk to you using private IP. VPC B will also accept that connection. Okay, I am fine, we can talk using a private IP. Okay, so for VPC peering we need a two VPC. It can be a same AWS account, it can be in another AWS account, or it can be in another region as well. So for VPC, just always remember it is peering. Peering means it is required that both the VPC can communicate using a private IP. Okay, so what is the need of VPC? If you need the instances in or resources in separate VPC needs to communicate using the private IP, then in that case we need a VPC peering. So first I will show you how we can make sure that instances in the same network can talk to each other or communicate with each other using a private IP. So let's first understand this diagram. So we have VPC A and it is having one subnet, and we have VPC B, it is having a subnet. Now there are some instances in VPC B, as I said, and some instances in VPC B and VPC A. Now they both wants to talk to each other using a private IP. So here we need a VPC peering connection. But only a peering connection will not work. We have to add entries in route table as well. So we have to, as we already discussed what is a route table, it is just map of direction where your traffic should flow. So whenever I am saying, okay, I need to go to the VPC B, then we need a destination, we need a target, how the connection should go. So suppose I want to reach to VPC B from VPC A, then here I have to make entry that, okay, if VPC A route table wants to communicate with VPC B, it should go to the peering connection. So that entry we have to make in both the route table. So route table of VPC A as well as a route table of VPC B. So that was a bit conceptual. Now let's go to the our console and we'll see how we can make sure we can create a VPC peering and we'll make it work to communicate each other using the private IP. Now I am in my VPC console, I mean within the instance. So let me just close unnecessary tab here. So I have a lot of tabs open here. I'll just close few of the tabs so we'll reduce our confusion. Okay, so first I'll go to my VPC. Okay, so I have demo VPC. I'll just filter with a demo VPC. Also I'll go to instance. So let me check what instances I'm having. Here I am having VPC. Okay, so let me check demo VPC. And so currently I am having two instances. One is in my private subnet and one within my public subnet. Okay, so I named it as a private, I named it as a public. So now we already seen, suppose if I want to access this one, so I already installed one simple Nginx application here and I can access it over the IP. Okay, so it will show a welcome Nginx. But suppose from my system, from my laptop, I want to access this using the private IP. Will it work? So let's try that. So I'll use a private IP instead of public. Okay, and I'll just try to run it using a private IP. So I'll just use and we'll see if it will work. It will not definitely work because I am using a internet to access my private IP. So there is no connection between my remote network to my instance in my public subnet or within my AWS VPC. But suppose if I go to my another instance in the same VPC, so I have two instances here. Okay, and now suppose if I go to a private virtual machines, I'll connect to this EC2 instance. Okay, we already saw how we can connect using endpoint. So we'll connect to this instance and we'll try to access this using a private IP, that is our private IP, and we'll see it can access the Nginx application. Okay, so we'll see that if they can communicate with private IP, we'll confirm that because these are part of the same VPC network. So why I'm showing that? So first we need to make sure that instances within the same network can communicate with each other using the private IP. So now if I do curl with this IP, so on browser we are just accessing from instance, we can just make a curl. So I'll just make a curl request. Okay, I think it was already there, so let me remove this. Okay, and you can see it's working. So thanks for using Nginx. The same thing, welcome Nginx, thanks for using Nginx. The same thing you can see here, welcome to Nginx. All these things, just it is in a HTML format. Now this is working fine on external IP, that is expected because we are using the cloud net here. Suppose we want to check this because on my system it is not working, so I want to check curl with a private IP. Okay, and let's see if it works. And you can see it works completely fine, the same way it works as it is working for external IP. It means my instance in a VPC A or my demo VPC can talk to each other using a private IP because both are part of the same VPC. Okay, so if I go here to my instance page, they can talk to each other because both are part of same VPC. So these are part of the same VPC, so they can communicate with each other even though they are part of the different subnet. Now for VPC peering we need a two separate VPC and we want to make sure the instances in a different VPC can communicate with each other with a private IP. So what I will do, I'll go to VPC and let's see if I have one more VPC here. So currently we are having demo VPC and we also have one default VPC. Okay, so you can see the default S. So I'll use the default VPC. So I'll just name here default. Okay, so this is our default VPC. And what I will do, I'll create one EC2 instance in my default VPC. So we'll just go to the instances. I'll just launch instance. I will again use the default configuration. Okay, and I'll just name it as a default instance. Okay, so we'll understand this is from the default VPC, and rest of the configuration will keep as it is. Okay, will not make a lot of changes here. Okay, so as we were doing till now, and now we need a default VPC, so I will not change this. Okay, so I will make sure default VPC security group. In default VPC there is existing a security group, so we'll just use that. So if I go to select existing and see, the default security group will use, and will launch instance. So now we are creating one more instance in a default VPC. So let me go to the instances. Now we should see a 3 instances. Okay, so we have 2 instances in our demo VPC, which is in private subnet, one is in public subnet, and also we are having a default instance in our default VPC. So it's still in health check is initializing status, but yeah, that is fine. So let me log in into this default instance. So your demo VPC or your default VPC already comes with all the configuration, so you do not need to worry about a lot of configurations or security groups, internet gateway. So in default VPC these things are already there, so you can directly go and connect using instance connect. So I'll just connect here. Now I am within my default instance. So let's see. So this is a private IP address of my default instance 172.31. So this is my private IP. Okay, now let's see, we are having this instance, so 10.0.25. so this is within my demo VPC. So earlier we were trying to access this. Okay, so this we are trying to access from the same VPC, and it was working fine. So this is not working because we are checking this in a demo default VPC. Okay, but if we test it from the same VPC with internal IP, it will work. Okay, so this nginx will come to it is working completely fine within the same VPC, but now this new instance is in another VPC and it is not able to connect or access the application using the private IP. It means the instances in different VPC cannot identify each other or connect with each other using the private IP. Now my requirement is that it should also work from the different VPC. So for that we have to make a peering connection. Okay, so I'll go to the VPC. Okay, so now we have two VPC. So currently the instances in my demo VPC can access to each other using the private IP, but my instance in default VPC cannot talk to instance in a demo VPC with a private IP. So for that I need to create a peering connections. I'll go to peering connections. Okay, I'll create a peering connections. Name I will just give demo2 default. I'll just give a peering px. Okay, I'll just give peering. It's big name. So VPCs, we have to select first local VPC. Now I'll select local VPC as a requester, so I'll choose a demo VPC. So my demo VPC is requesting peering connection with other VPC. Which is other VPC? This is a default VPC. Now if it is in the same region or another region, you can select here. So it is in the same account and same region, so I already selected here. Now just make a note of IP ranges. They should not be overlapping. So my demo VPC IP range is 10.0.0./16 and my default is 172.31. so these are not overlapping. Now I can just create a peering connection. Okay, so now it will say pending acceptance. You can accept or reject this peering connection a request using the actions menu. So I'll go here in actions menu, and we have option here to accept because my both are VPC, the requester and acceptor both are in the same account, same region. Okay, so I can have option here to accept. So I'll just simply accept it. You can see request account ID same, SIPTA counted is same, region also same, so I'll just accept. Now it will become green and available. I am making peering between these two VPC. I am just making connection between these two, and now you can see to send and receive traffic across the VPC peering connection, you must add route to the peered VPC in one or more of your VPC route table. Now I'll still check if it is working. Earlier it was not working. Now we have made a peering connection, and let's try now. It is still not working. Okay, it means we still need a route. So I'll go to VPC and I'll go to first. I will go to a demo VPC. First I'll go to demo VPC. In my demo VPC, this is my route table. I'll just click on the route table. Okay, I'll just check the route. Okay, and I need to add a route. So what route I need to add? So for that, let me get the range of my another VPC, that is for a default VPC. So it is just like for VPC A you will give address of VPC B, and for VPC B you will give address of VPC A. So it is just vice versa. Okay, so I'll just check the address of default VPC now. So I'll go to default VPC and get the CIDR range for my default VPC. So how I will decide my routes? So this is IP address, IP range for my default VPC, and I am updating the route table for my demo VPC. So here I'll just give the range. Okay, so if any traffic wants to go to this default VPC, it should go via a peering connection. So here, what is a peering connection? This is the peering connection. I'll just save the changes. Okay, so my route table is updated. So for this it will a local IP, for this one it will go through peering connection. Now let's see if it works. Okay, now you can see it's still not working because we need a route in a default VPC as well to send the traffic back. So I'll just close it, and now I'll go to default VPC. So where is my default? So this is my default VPC, and okay, let me go back, and this is my default VPC route table. So I'll just go to the default VPC route table. Okay, and I'll check the route here. So currently this is not having a route for my demo VPC. So I'll just edit the route. I'll just give 10.0.0.0/16, that is the range of my demo VPC. So whatever traffic should go through this demo VPC should go through a peering connection. So I'll select the peering connections here and I will save here. So now both the route tables are updated. My VPC, that is default VPC, also having entry in a VPC route table, and also my demo VPC is also having entry in the route table. Now let's see if it works. So in earlier time it was not working. Let's try now. Okay, it is still not working. Why it is not working? We'll check. We also updated the route table. So we updated route table. Let's check what our subnets are using, which route table they are using. Okay, so our private subnet or public subnet is using the different route table. Okay, so this is my public subnet route table. So we have to add entry here as well. So we'll just add entry here as well. So whatever traffic should flow for a default VPC IP range, this should go through the peering connection. So this is my correct route table because my subnet is not using the main route table. This is using the separate route table. Now let's see. Okay, now it is working. So earlier it was not working for a private IP, but it is now working for private IP even if it is in the different VPC. So in this way we just created a peering connection, we updated the route table, and now the two instances in different VPC can communicate with each other using the private IP. So hope you understood what is peering now. So just always remember the few steps here. First, you need to create peering, you need to accept the peering, and then you have to update both the root tables. So you have to update the root table which your instances is using in VPC A, as well as the root table which your instance is using in VPC B. So that are the three steps required to make sure your peering is working completely fine. So that's it for peering, and we'll see further. We have covered most of our things in AWS networking. Let's see if we covered all things or few things are still pending. So let me go to our slide pack. So this is our slide, and here we have check networking basic, IP address, CIDR range. We check the VPC, subnets, public and private. We created route table, which default VPC. We worked on internet gateway, we worked on NAT gateway. VPC endpoint is remaining. Okay, fine. Then we worked on a NACL, security goose, VPC peering also worked, and then transit gateway, VPN, and AWS direct connect. So now we'll check for a VPC endpoint. So we'll see what are the VPC endpoints and when we should use a VPC endpoint. Okay, so here you can see an AWS endpoint is a network interface that allow communication between your VPC and other AWS services without requiring access to the public internet. Now let's suppose we have a virtual machine in our private subnet, and that virtual machine need to access some data or some file from the S3 bucket. But ideally it should require internet, because whenever you try to access the S3, the traffic will go through the S3 over the internet. But now both are AWS services, and I just don't want egress charges. I don't want to expose my resources to the internet. So what is a way? We just want to access internally because both are in AWS network. So in that case we have option for a AWS endpoint. So there are two types of endpoint. First is interface endpoint, which is powered by AWS private link, and we have a gateway endpoint. So now you can see the right side diagram here. So interface endpoint will be used to access most of the AWS services. You can see the list here: API gateway, cloud formation, cloud watch, and lot of services here. And VPC gateway endpoint, so this will be used to access your S3 and DynamoDB. So as of now the gateway endpoint support S3 and DynamoDB. So now we'll go to our AWS console and we'll try to see how we can create an endpoint from our private VM to access the S3 bucket. Okay, so let's just go to the instance and we'll try to see one of the private virtual machine. Okay, so I have these three EC2 instances. So I have a private VM which is within my private subnet. You can see this is not having any public IP, so it is having private IP. So I'll just connect to this instance, and from this instance I'll try to access the S3 bucket. So let's first see if we have any S3 bucket created, or let me create one S3 bucket. I'll just go to S3 and I'll quickly create one S3 bucket, so at least we'll see some response whenever we try to access a S3 bucket. So let me create one S3 bucket here. So I'll just go here and quickly create one S3 bucket. Okay, so I'll just give the name as sample S3 bucket. I'll keep the settings as default and I'll just go and create bucket. Bucket already exists because bucket name should be globally unique, so I'll just append G01 here and hope it will be unique. And let's try to create bucket now. Okay, so we have created the bucket and we already into a private EC2 instance. So we are using this instance which is not having any public IP. And let's first see if it can able to access the internet. So I'll just do ping google.com. Okay, we are getting response, so it is able to access the internet. Why? Because we are having a NAT. Also see if it can access the S3 bucket. Okay, so unable to locate credentials, you can configure credential using AWS configure. So I'll just do AWS configure. Okay, AWS access key ID. So we have to provide this access key ID. So let me provide that. So till the time I'll just pause this video, because how to configure AWS CLI that you already know. So you can skip this part. I'll have a separate video to how to configure the AWS CLI, how to add this access key, where we can get this access key. So but here I'll just add the key and I'll just be back. Okay, so for this I should be having IAM users to be created, so I'll just go to the IAM. So I'll just open the IAM page here and I'll create one dummy user there, and we'll use that credential to access this S3 bucket. Okay, so I'll just go back. I'll go to IAM. Just create the user here. I'll just give the name dummy user. Next, attach policies directly. So what policies I need S3 access. So I'll just check the S3 full access. I'll give this as access. Okay, and I'll just click next, create users. So once this user is created, we can create the credential for these users. So this user is created. Okay, and now we can go to security credentials. We can create access keys. So we need for CLI. Next, so just you can use the tag as a CLI, create access key. Okay, so you can copy it here, key ID, paste here. Okay, now it's secret key. So I'll just copy the secret key from here and I'll paste again here. Okay, default region. So I'll give this as a default region, AP South 1. Okay, none. Okay, and now I'll just try to execute AWS S3 LS. So it is giving my bucket which we created as the sample bucket. Now this is able to access the google.com as well as the S3 bucket because it is having internet access through a NATGateway. So let me show you that. So it is also having access to google.com. Now what I will do, I'll just go to this instance. Okay, and this is part of the public subnet. So if you go to networking, so this is part of the public subnet, private subnet, and this private subnet is having the private route table which route traffic to the NAT gateway. So I'll go to the route table, and this is our private route table, and here the traffic is going to the NAT gateway. So I'll just delete this NAT gateway route. It means I just removed the internet access from my virtual machine. So now if I execute the same thing, so you will not get any response. You can see you are not getting any response. So all 100% packet loss. Also try to access the 3. So it is not showing in the bucket as well. No, it is not able to access the S3 bucket as well. So we terminated internet access from this EC2 instance. Now here is the points come when we have to use the VPC endpoint, and here we'll be using gateway endpoint to access our S3 bucket with the private network. Okay, so how to create gateway endpoint here? So from VPC, you just go to the endpoint, create endpoint. Okay, so I'll just give S3 access. So we have to access the AWS service. So services, there are a lot of services. As I said, there are interface type endpoint as well as the gateway. So if I type S3, so there are two services type endpoint. One is gateway, one is interface. We want to use the gateway. So I have selected the gateway endpoint. VPC will select our demo VPC. Okay, route table will be our private route table, and full access, and let's create endpoint. Okay, so successfully created our gateway endpoint. Now let's try to access now. Okay, now you can see without internet access it is able to access our S3 bucket. Google.com it will not access because we terminated internet access. Now can access the AWS services without a public internet. So that is how we can use the endpoints. So we just see how we can use a gateway endpoint to access the S3 bucket from our EC2 instance. So now hope you understood what is a VPC endpoint and how we can use S3 gateway endpoints. We almost covered all the components of AWS networking. Let's see what else is remaining again. So now we are remaining with a last component, that is transit gateway, virtual private network, and AWS direct connect. So these are mostly used for your hybrid connectivity when you want to connect your AWS network to the on-premises or your data center. In that case, these things will be used, mostly the VPN and the AWS direct connect. So currently I do not have any on-premises network to explain, but I'll try to create a separate videos for transit gateway, VPN, and AWS direct connect, because this video is already getting too longer because we have covered almost all the things from AWS networking. Okay, so hope you enjoyed this video and you learn a lot of things from video. If you are still not clear with any of these networking concepts, just let me know in comment section and I'll try to help you out. You can set up call with me and I can help you, I can guide you to just get your understanding clear on this AWS concept. So thank you for watching this video and we'll see you again in next video.